Welcome to the MSJC Internet Authoring Videocast.
Welcome to CSIS 113B Lecture 11. In this lecture, we'll be discussing custom objects. Here is a little more detailed look at what we'll cover in this lecture. We'll start out by talking about what a class is. Remind you that it is essentially a blueprint for an object. We'll talk about class access modifiers, public, private, and protected. Generally, you'll be only using public. We'll talk about defining the data section of a class. We'll also take a look at creating a public interface for the class, in addition to the accessor and mutator methods, which are also referred to as getters and setters. And then we've got an example for you. It's called a fraction class. We'll take a look at that and then get into some of the details about building the class. For example, we want to make sure you understand that you want to separate your class from the GUI so that it becomes a reusable blueprint that can be used in many different GUIs. We'll also take a look at how to create the constructors for your class. We cover a little bit about composition. We've got an example there where we combine a JLabel with a JText field into a new custom class. And we'll also be talking about object arrays. So what is a class? Well, technically, a class is an encapsulation of data and methods that operate on the data. So as we go through this, you'll see that the methods that we write will always perform some sort of action on the data. And throughout this lecture, we're going to use an example, which is a class that we have named fraction. So we want to basically put together all the components then of the fraction class to demonstrate how to build a class. Some of the keys you want to be aware of at this point in time: you can only have one public class per file, and the file must have the same name as the class name. So in the example here, where we're creating the fraction class, we would have a fraction.java file that would contain the source code for that class. And you can see logistically there that we have an access specifier, or access modifier it's also called, of public, which is generally what you're going to use. We'll talk a little bit more about public, private, and protected here in just a moment. Then the keyword class, followed by the name that you want to assign to that class. So that whole line there with the access modifier and the name and the keyword class is referred to as the class header, just like in methods where we have a method header. And then we use, just like we do in methods, curly braces then for the actual statements that we want to use to write the source code for the body of our class. So as we just talked about, we have these access modifiers that we can use: public, private, and protected. And when it comes to classes, generally speaking, you want to always use public. You cannot generate a public class, in other words, an instance of a public class into an object, if you make it private. So public is generally the way that you're going to want to go as far as the access modifier designation of your class. So public class just means that all members are public by default. You can go in and specifically, and we'll show you a demonstration of that, you can specifically define that some of your methods, or specifically really the data portion of your class, will be designated as private. A private class would mean that all members are private, again by default, but that does also prevent us from being able to create a public instance of that private class. So that's why we say it's just general rule of thumb from this point forward until you're told differently. Go ahead and use public for your access modifier when you're designating the header of your class. And we will talk about protected a little bit later on. You get that actually in level 2 of this class when you get more into classes and more detailed explanation of different ways of setting up your classes, and specifically when you start talking about inheritance. So generally speaking, again, make sure you just always use the access modifier public when you're generating your classes. As we said in that early definition there, that a class basically consists of data and then methods that operate on that data. So the data section of your class, as you can see in the example here, you should always create the variables, which are going to be the data in your class, using the private access modifier. That way, somebody who's using your class cannot accidentally or perhaps intentionally put values into that class that may make the class crash or become a security issue of some sorts. So it's generally accepted that whenever you create your class variables, your class data members, that they should be private. Now, the example that we're looking at here is that since we're going to be creating this class called a fraction, then it makes sense that we need to have a value that we store for the numerator and a value that we store for the denominator. And so that's why the example is showing you there that we create two int types. One is num for the numerator and the other is den for the denominator. So because your data section is private, we do need to create a public interface so that others can interact with that data. But by creating our public interface, what we can do is we can actually then control how that data is going to be stored and then accessed by outside users. So in the case of our fraction class, we're going to add 4 different methods: the add method, the subtract method, the multiply method, and the divide method. Now, we also need to be able to assign the values to those 2 variables that we looked at just a moment ago, the numerator and the denominator. And we'll do that using another method called set fraction. So that's what we call a mutator method or a setter method, because we're going to set up some statements that take the value in from the user, but then also evaluate that value to make sure that it's safe and secure and can be stored into the class. So generally speaking, when you're creating your custom classes, it's good to think of it as all the methods that you create are going to manipulate the private data section, in this case here, our numerator and our denominator, in some way. So these are the methods that will be public. Those are the ones that the users of our class will be able to use to assign values, numerator, denominator values, into the fraction class, or retrieve or create some functionality on the numerator and the denominator by using the add, subtract, multiply, and divide methods that we provide. So those will all be public. That is the public interface then for our class. So again, specifically what we're talking about are mutators and accessors, or getters and setters. So the accessors is when we get values, get the data from the class. So once we store data into the class, we'll need to retrieve data from that class. So that's going to be the accessor methods, also known as the getters. And then when we assign values into the class, which initially would be for the numerator and the denominator, that would be called a mutator or a setter, because we're setting the value of the data at that point. So anytime that you're modifying the data, it's a mutator. Anytime that you're retrieving, reading the data, it's an accessor. And just as examples, you've seen this as other classes that you've used previously. So some of the accessor methods that you have seen were get text and get background and get foreground. And then the mutators is, again, change. They mutate the private data. And you've seen these before with set text and set background and set foreground. So just realize that you've been using all up until this point classes that were created by some other programmer, and they provided you with access to be able to retrieve the values and then mutators so you could make modifications to the data. So here's a quick overview of our fraction class. So we're using the header there, public class fraction. So that's our accessor method, the keyword class, and then fraction. Notice there's no void there, right? Classes do not return a value like a method does. The methods inside the class will provide us with values, but the class itself does not return a value, so you don't even put void in the header there. It's always just going to be public class and then the class name. Then we have the data section. We have our 2 integer types that we've defined there as num and den, so numerator and denominator. And then you can see that we're going to create several different methods, as I mentioned to you before: the add, the subtract, multiply, divide, and then the set fraction methods. And these are referred to as stubs at this point because we actually haven't put any statements inside of those methods. So it's important to kind of change your way of thinking, because up to this point you've always been using just the same one Java file when you write your source code. But now that you're starting to create your own custom classes, what you're going to need to do is separate the class file from the actual GUI file. So the GUI will be the main, will have the main method in it, and that's where the program is going to be invoked from. And you'll create instances then of your classes inside of that GUI main method. But you don't want to create the class within the same file that you're writing the GUI code in. And there are exceptions to that. There are times when it gets kind of hard to distinguish. If you have very basic games, you could have the GUI built in, but technically speaking, strictly speaking, you really want to create classes separately from your GUIs. So you need to ask yourself, can the class be used in another program? Is that your intention for creating the class? Because if that's the case, you definitely do not want to put the GUI components in it. So again, you're going to create the instances of the class in the class that contains the GUI. So object-oriented programming is typically a group of cooperating objects. We have classes communicate with each other. So you've got the GUI class, which then invokes your custom classes. And as you have seen, when you use some of the built-in classes that come with the Java SDK, in order to create a new instance of the class, which essentially is then how we generate an object, you have to call the constructor of the class. So that's a very special method that we build into our class that may or may not have data passed to it. It just kind of depends on the type of class that we're building and the details that will be inside of that class. But if we do have a data section that needs to be initialized, then generally speaking, we probably will be passing some sort of values into the constructor when we generate the new instance of the class. So just as a reminder, in the graphic there, you can see that we're using the J button as an example, and then btn equal to new J button. And then remember, if you put in the constructor's parentheses a text string, that's the text string that actually appears on the button. So that's what you're seeing in the graphical example there. 3 things that you need to know about constructors. Typically, we define them as public, not always, but in most cases. Constructors have the same name as the class. So if you look at the example on the right there, you can see the class header, which is GUI app extending from JFrame, but then the constructor method is public as well, and then the only thing that we add to that is the name, and the name has to match the class name, and then a set of parentheses after it, because it is a method, but it's a very special method referred to as a constructor, because that's the actual method that will run when we create a new instance of this class. And you've been doing this already, so hopefully you feel comfortable with it. And then constructors, like a class, they have no return type, not even void, because all they're doing is just basically setting up the class when we create the instance of it. So just like your methods, you can have overloaded constructor methods as well. So you need to get used to the terminology that we use. We've got constructors that have no arguments, is just called the default constructor. And you really don't even have to create the default constructor unless you add in overloaded and or working constructors. So if the only constructor you need is a default constructor, you really don't have to create it, because the Java virtual machine or the compiler would actually create that default constructor for the class. But more than likely, you're going to have overloaded constructors, just like we had overloaded methods. So in other words, they can take varying numbers of parameters can be accepted of different data types. And you'll see there's one specific constructor referred to as the working constructor. So we'll show you an example of that here in just a little bit. But that's the constructor that would take all possible arguments. So all the different parameters, if you needed to assign, if you got 3 different data types in your class and you needed to, when you initialize that class, have those 3 data types be assigned each a value, then the working constructor would accept 3 arguments so that it could then take those arguments in and assign them to the actual data that's in the data section of your class. And what you'll see when we set this up, because we'll have several different constructors, including the default constructor, we'll have them called the working constructor. And we'll do that by using the this keyword. And you have to think about it too, is that anytime we say this, what we're referring to really is that particular constructor. And so in the parentheses after the keyword this, that's where we would put in any of the parameters that we'll be passing to that working constructor. And we'll give you an example of this in a bit. Here is an example of an overloaded constructor. So the very top method that you see there, public GUI app parentheses, is just going through and setting up all the basic components for this GUI app. But then further down you see that we have another constructor method, and we know it's the constructor method because again it's using the same name as the class, which is GUI app. And that constructor, you can see, is accepting as an argument a string named title. And so what it's doing is it's actually going to override the set title by taking the new value there that's passed in from the user. When they create the new instance, they'll be passing in a string that's a title, and so then they'll assign that value to the title of the new object, which in this case, as you know, is a J-frame. In that bottom case, then, that's another overloaded constructor because it takes in the height and the width. So if the user generates a new instance of the GUI app, says new GUI app, and then passes in 2 integer values, that will be the constructor that's used to actually create the instance of the GUI app. Now this would be a working constructor example. You can see that in this particular constructor method, it takes in the 3 data types that are necessary or that are possible when generating or creating a new instance of the GUI app. So it accepts a string that's going to be title, it accepts an integer which will indicate the height, and an integer that indicates the width. So then internally you can see it's using the this keyword and then the various methods there, set title, set size, and applies to it the value of title, the value of width and height that was passed in from the user. And then on the far right there you can see is the default constructor. So in this case, since we have a working constructor, the default constructor, and we know it's default because it only has a set of parentheses with no arguments being accepted, you can see what it's doing is it's using the keyword this, which means actually we want you to call the working constructor and then pass to it these default values. In this case, extend from frame is going to be the title, 400 is going to be the height, and 300 is going to be the width. And it takes a little bit of getting used to. You do it a few times, you'll get used to it. So as we've been building these GUI apps, you actually have been doing composition when you think about it, right? We've been taking all these custom classes that have been built by other people, we've been using them within our own GUI app class, and we've been actually combining those elements all together. Well, you can do the same thing if you want to create a custom class. The example that we have here is that we're creating both a label and a text field into a single class, so that all we have to do then is just use that single class anytime that we want to have a label combined with a text field in the form. So we still would have to import the swing and the AWT packages to be able to create this custom or composed class that we want to create here, the one that has both the label and the text field combined with it. And if you think about it too, I mean, the reason we're doing this is if you think about business forms, anytime that you see a form, basically you always have a label to the left and then the input text box to the right of it. And so that's what we're trying to set up here. And then the other question here is, what do we want to extend from? And so for our example here, we're going to use a J panel. So remember, a J panel is just a way of combining multiple elements together. So the J panel then will be kind of the outer wrapper for our class, and then we'll add to it the label class and the text field class. So here you can see that in our public class, which is label TF, we've extended from JPanel, and now we're creating an instance of a JLabel, passing to it a value of name as a string, and then also a JText field being created, an instance of a JText field being created, and it's going to be 10 columns in size. Then we have a constructor method down below that. You can see that we're just setting up some of the basics for our JPanel here. So we're setting the layout to be a flow layout, and then we're adding into it the label caption and the text field input that we created up above. Now once we create that custom class, now we can go back to our GUI app, which this one, remember, is extending JFrame because we put our panels inside of JFrames. And so if you look at the first outlined box there, you can see we're just creating a new instance of our LBLTF class, just calling its generic or default constructor. Then below that, we actually have the constructor for the GUI app, which is setting up all the basics of the JFrame there, the title, the size, its visibility, its default close operation, setting its layout to flow layout as well. But then finally, we're adding our LT variable, which is the instance now of our LBLTF class, our custom class. And if you look to the right, you'll just see there is what it would look like if we were to run that GUI app at this point in time. So again, just like I said, combining a label with a text field and input. So going back now and modifying our LBLTF class, you can see that we're adding accessors and mutators now. So if you just look below the default constructor there, you see we have a set caption method. We've got a get caption method. So remember, get caption is the accessor method, set caption is the mutator method. And then we also have a set text and a get text method. So after the user of our class creates an instance of our class, they can use these methods to actually change the text of the label caption, change the text of the input, and then also get the values from each of those if they need to. And that also makes it a lot more flexible when you think about it. It makes our custom class a lot more flexible, because now what we can do is, instead of accepting that default value of name every time that we create a new one of our LBLTF classes, now we can actually change the value of that label. So in this example here, as you can see, we're setting the caption of the second label to address. So moving into a different direction now, we want to take a look at array objects. And so before we get to that specifically, just reminding you of how arrays work. So generally speaking, when we create an array, we put in one of the primitive types before the square brackets to indicate the type that that array is going to store. And then using the new keyword, we can initialize then the array with how many elements we want it to have. So what you're going to see is the difference between a standard array, which uses the primitive values or stores the primitive values. When we get to object arrays, now what we're talking about is actually storing objects in the arrays. So in this example, now you can see we're creating an array of J buttons. And one of the important things that you want to understand is, if you think of how the standard array works, when we were putting integers in there, they had a default value. Each integer that was placed into the array had a default value of 0, because that's the way primitives work. But when it comes to objects, it will not have a default value of 0. Objects, until they've been initialized or assigned some sort of a value, will be null. And so that's what this example is showing you here. We do basically the same thing. We still use a type identifier, because classes are types. In fact, you're going to even see that we have types or classes that are created for integers and doubles and all the primitives that you're used to using. In this example, we just happen to be using a JButton, which you know is a class. And so we're creating an array of JButtons, calling it BTN, and then same format, using the assignment operator, new keyword, and then JButton. We're saying then create a new array, a new object array of JButtons, and we want to have 5 elements to hold those JButtons. But we haven't actually created an instance of a JButton to store it in the object array yet, and so if we were to take a for loop right at this point and go through and look at each of the elements and see what their values are, you would see what you see in the screen there, which is each one would be null. So now in this example, you can see we're creating an instance of a JButton and passing a value of 1 to it. Remember again how JButtons work. When we pass a string to it, that's the text that's going to be on the button. So we're assigning that into the first element of our object array here. So you can see that in the graphical example. The other elements still have not been assigned an instance of a JButton, but the 0 element has, and so that's what the content of that element is now, is a JButton with the text 1 on its face. Now obviously there's an easier way to do this, which is with a for loop. You wouldn't do that one at a time like in this example. And so here is the easier way of doing it, which is using the for loop. In this, each time through the for loop now, we're creating a new instance of the JButton. In this example, we're just incrementing the value of I each time we go through the for loop. So that's going to be the textual value being assigned to the JButton. So at the bottom, you can see now with the for loop, we've gone through each of the elements within the array, created an instance of the JButton each time through, and assigned a unique value to each of those button faces. So that wraps it up for Lecture 11. We talked about what a class is, talked about the various access modifiers, basically saying stick to public anytime you create your own custom classes. We talked about the fact that there's essentially 2 sections within a custom class, the data section and your method sections. We talked about creating the public interface, which are those methods that will retrieve or assign, get or set values for our custom values, our custom data section in the class. Remember, the data section itself wants to be private. We talked about the fact that those methods that access the data and modify the data are the accessors and the mutators. So the accessors will allow us to retrieve values from the data section. The mutators will let us modify the values of the data section. And then we showed you the fraction class example. We talked about keeping your custom classes separate from your GUI class. So the GUI class is going to be the front end really for your application now. That's where the code's going to run from, is the GUI class. And in the GUI class, you'll create instances of your custom classes and then use them in the GUI. We talked about the various constructors, default constructors, the overloaded constructors. Talked a little bit about composition. We showed you how you can take other classes and combine them into a new class to kind of simplify how you're building your objects, building your components into your applications. And then we wrapped it up with object arrays, defined for you that that's a little bit different than using just a standard array where we stored primitives. In an object array, you are, as the name implies, going to be storing objects in there. And the main thing is to know that the value null is assigned into each of the elements before we create an instance of the object that we want to place into the array for each of the elements. So that's it for now. Until next time, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.